Welcome back, friends. Let's look into another question on method of sections. In this question, we are given a truss in which the different loads are acting, and I wanted to apply the method of sections to find the answer. So one thing I'll again repeat it: when you are asked to find the load in all the members, we generally use method of joints. When you are asked to find the load in particular member, we generally use the method of section. So in this, I've been asked to find the load in BF, so it's asking me to find the load in one member, so I'm going to use the method of sections here. So what I'm going to do is I'm going to cut it from somewhere here. So if I cut it from here, the one thing you need to remember is if you're trying to find the load in a particular member, make sure you section that member. So I wanted to find the load in this BF, so I will make sure that I section that particular member. Only then I'll be able to get the answer. So that's the first thing. And the second thing, now I can use this portion also. This diagram is converted into two different blocks. I can use the top portion or the down portion. If I have to use the down portion, then I have to find the reaction load. So you can do it by using the portion which is at the bottom, this portion also, or you can do it using this one. Right now I'm going to try and solve this question using the top portion. So this is the free body diagram which I'll come across. So what I've done is I've done nothing but just cut it from here, and then whatever the top section is, I've drawn it at this point. Now, one of the most interesting point is I'm going to erase this first of all. So this is the free body diagram which you can see. Let me change the color. So this is how the free body diagram will look like. Now, in these questions, what you can do is, where the students sometimes confuse themselves, then they think that this point B is not the part of this diagram, the point B, but we can always extend the member which starts from C, which we sectioned, we can extend it to point B also. Or so I'm going to extend this and I'm going to join it over here, and then I can always take the moment about this point B also. So I can use this point to my good effect. So let's say I'm going to take a moment about point B. Taking moment about B. So if I take the moment about B, so FG is trying to rotate it in clockwise direction, and then the perpendicular distance of FG is how much? 4. So FG times 4, which is negative because it's trying to rotate in clockwise. Then this 20 Newton load, which is acting in the downward direction, this is trying to rotate in clockwise direction also. 20 times 4, negative because trying to rotate clockwise. And then minus this 15 load, this minus 15 times this will be 6. Let me put a multiplication sign here, which is equal to, is there anything else? There's nothing, so is equal to 0. So that's what the equation will look like. So now we will try and find the value of Fg. When you're going to do this calculation, the Fg value will come out to be negative 42.5 kilonewton. So we figured out the Fg value. Now and one of the interesting question you can ask here, why we haven't considered the Fb value? Because I'm taking the moment about point B. So any force which is passing through point B, so if I extend this arrow, this is passing through point B, so I will not consider the load in this member in BF. So CB is also passing through point B, so I won't consider the load in this member also. So thus I will only consider the loads which are given to me, like 20 newtons and 15 newtons, and the third one, which will I consider I'll consider the effect of the member Fg, because I've sectioned that member, and I will not consider the unsectioned members also, like these ones. So I will not consider the effect of these members. That's really important to know. So now I figured out the Fg value. What do I need to do now? I wanted to find the Bf. So find BF. So what I'm going to do is I'm going to take the moment about point C. So sigma MC is equal to 0. If I take the moment about point C, the equation will look like negative 15 times 3, because the perpendicular distance from point D to point C is 3, and then negative FG times 4 minus 20 times 4 negative 15 times 3. So that's how it will look like. And is there something which I'm missing? I am missing FB value, minus FB times, what I'm gonna do, I have to change the color first of all. I cannot, there are two components of FG. One is passing through point C, and another is perpendicular perpendicular to point C along the FG direction. So it is along the FG, so I will consider this component, but this component will be 0 because this is passing through point C. So FB times this value will be 3 over 5 because of the slope. So if I consider the slope here, this is 4, this is 3, so this is 5. So I will consider this one as 3 over 5. So that's why I've put it as 3 over 5 here, and times, I will times it by the perpendicular distance, which is 4, which is equal, now this is equal to 0. And when I'm going to solve